Okay, hi everybody. We'll do a quick revision on vector diagram drawing. Okay, first of all, you need to know, of course, the definitions for vectors, scalars. Okay, vectors have magnitude and direction, whereas scalars only have magnitude, right? And know some examples. Okay, this is just a few. Okay, main focus I'm going to do is how to draw a vector diagram, right? Now, if the vectors are parallel each other, it's very simple. You just add them both up. Okay, you will get the resultant vector, right? So 120 plus 80 is, so resultant force is 200, or even its opposite, no problem, right? The problem comes when things are at an angle to each other. So for example, over here, right? Over here, when these two vectors are at an angle to each other and there's an angle of 70 degrees, how do you find the resultant force? Okay, I do have a checklist over here in my notes, okay, which you should have. Okay, if you don't have, you can pause and look through it. But most people don't like to read through so much, so I'll quickly explain what you can do. Okay, so in this situation over here, you want to find a resultant force between 80 and 120 newtons. Okay, before you do actually go and problem solve, I would suggest do a sketch. Okay, just do a rough sketch so you have an idea what you're doing. So for example, in this case, right, you see 80, 120, 70 degrees. Note all the vectors that are involved. Okay, so you have a starting point. Okay, and from this starting point, okay, all your vectors emerge from it. Okay, so the easiest to draw is 80 first. So you know that 80 is going to be somewhere in this direction. Okay, and then 70 degrees from here is 120. So you draw this again out from the starting position, you will look something like that, right? So this is 70 degrees, okay, and then after which complete the parallelogram. Okay, complete the parallelogram. Okay, and now here's the most dangerous part. Okay, after you completed a parallelogram, okay, where's the resultant? Some students will say here, some students will say here. Now how do you make sure you get it correct all the time? Okay, you make sure you get it correct all the time is by having a starting point. So the starting point, all your vectors emerge from it. 80 comes out from this, 120 comes out from here. So likewise, my resultant force will also come from my starting point right across to the other end. Okay, so that is my resultant force. Then after that, you just have to measure this length, okay, and according to your scale, you convert it and get the magnitude of the resultant force, right? And then to get the direction, all you need to do is measure an angle, let's say this, okay, and then state that the resultant force is how many degrees from the 80 Newton force. Okay, so that's about it. It's quite easy to do, right? So when you are doing it, okay, you just have to be very careful, right? With your measurements, your angles, okay, and always, as I always say, choose a good scale to represent your vectors. Okay, so something sensible, let's say, okay, that can give you a good large vector diagram. Okay, the bigger it is, the better it is, right? Okay, and always don't forget your arrows, right? Don't forget to draw your arrows, okay, and label the diagram, right? Okay, so that was not too difficult. It can be quite straightforward like this, right? So sometimes you are maybe given slightly, well, maybe you will think harder questions, okay, or you must be more careful with them. So for example, like this over here, you look at this, you might think, okay, all I have to do, okay, in this case, I see a vector, the velocity of current is this way, the velocity of the boat is this way, okay, so I just complete a parallelogram like that, and then I draw resultant force. Okay, well, that's wrong. Okay, why? You notice this vector is going this way, this vector is going this way. Now, as I said, have a starting point. So do a sketch again. Okay, so a sketch of what you really want to draw. So I have a starting point. Okay, I have a velocity of a boat. Over here, I can represent this one first. Okay, this is going to be about, maybe I choose 10 cm, right? 1 is to 1 meter per second. So this, you can imagine, is 10 meter per second. Now this one, okay, this is my starting point. I have to shift this vector so that it starts from my starting point. So the best way is to move this down here, right? Now you can shift vectors. Don't forget you can shift vectors. As long as you keep the length of the vector the same and the relative direction the same to the other vector, you can shift. So I shift this one down towards here. So it will look something like this. So you look something like that. So this one will be 8 meters per second, right? Then here was 70 degrees, so this would make it 110 degrees. Okay, so then this is my starting point. This one comes up straight up 10 meters per second, this one 8 meters per second. And then where's my resultant? All I have to do, complete my parallelogram. Okay, complete my parallelogram. Okay, then a resultant, again it comes from my starting point. So the starting point is very useful. It helps you make a mistake of where is your resultant vector. You won't draw it here. Instead you see starting point, this one comes out here, this one comes out here, so my resultant vector will come out in this direction, right? So you can call this the resultant velocity, right? And then again, you will then just measure the resultant velocity, all right, using your scale and get the answer, okay? And then you need the direction. You just have to measure angle, label it, right, and say, okay, how many degrees this is from 8 meters per second, right? So do a sketch first. After you've done a sketch, you have an idea, okay, what it should look like. Then you go and use your ruler, protractor, and draw accurately. Okay, so be careful, right? So this one you have to shift the vectors, right? Okay, sometimes there are other questions, okay, they try to confuse you, okay, don't be too confused, huh? So even if let's say you're given a diagram like this, okay, the girl is held by 2 elastic ropes. Okay, read the question. Maybe you can pause it here or look back at your notes how you did this. And then in this case, they gave you part of the vector diagram. Okay, this one they're trying to help you, right? So all you need to do is again complete the parallelogram. Okay, in this case, okay, measure this to get what scale they are using, find the resultant, right? And this resultant, okay, this resultant force will be what you the resultant force of the 2 elastic ropes, right? Oh, sorry, that will be, yeah, okay, that will be resultant force that's going to propel the girl upwards. Okay, so it's not too difficult, right? Okay, so and other times maybe you get a diagram like this where there are seemingly many vectors. Well, that's just the wind. Okay, so again, shift. You got to shift again. Where do you want to start your starting point? So again, sketch. Okay, so cyclist is here, so maybe a starting point like this is good. Then just shift this here. Okay, and your math skills will tell you, okay, then this is the wind, this 3 meters per second, this 8 meters per second. Your math skills will tell you, okay, since this 50 degrees, okay, then this will be 40 degrees. Okay, and then again, complete this parallelogram. Okay, do a rough sketch, and then you know the resultant velocity is this way. Then after that, again, draw accurate diagram using a ruler and a protractor. Okay, so it's not too difficult, right? Okay, now then another example is this. Okay, sometimes students get stumble over this question. Again, you want to pause and read the question again, or look at your worksheet. Okay, so here you have a board. Okay, it's 0.5 kg. And it's being pulled by a 3 Newton force here. So in this case, they didn't give you all the forces. They didn't label for you the weight. So the weight is what? Acting downwards. Okay, and this weight would be 0.5 kg into weight is 5 newtons, right? So what you have here, they're asking you to determine a tension. How do you get this tension? Well, this tension is equal to the resultant of these 2 forces. So the result of these 2 forces, okay, will be somewhere here, the resultant force, okay, will be equal to the tension. So you find the resultant of these 2 is equal to the tension. Okay, so sometimes they don't label for you all the forces, you label yourself. And then again, as I say many times, I'll do a sketch, and then you'll be able to figure out clearly what you need to do. All right. Okay, so maybe let's look at one last example. Okay, so sometimes the MCQ questions like this. Okay, again, you can pause and have a look at this question, or refer to your notes again. So you have a boat, okay, a ship rather, okay, that's being pulled by a force F1 and F2, right? And they ask you which one shows the resultant force R. Okay, so you do a rough sketch. So you think, okay, F1, okay, f2. Okay, right, so you do a rough sketch, okay, and it's 60 degrees. Then if you were to draw a parallelogram, you know that the resultant would look something like this. Okay, then from the something like this, okay, you have to see, okay, where's the resultant R. Okay, obviously these are not parallelograms, they are triangles, so you need to shift vectors. Okay, shift the vectors so that it resembles one of these here. Now which one is it, right? So you look at this. Okay, so this one, remember you can always shift vectors. So this one, f1 is here, I can always shift f2 to here. Okay, so if f2 is shift here, is the same thing. Alright, so be able to be comfortable with shifting vectors. I can shift this one here, right? Or I can shift this vector down to here. Okay, it will be also the same thing. So I don't move f2. Okay, my f1 comes across here. It's the same thing, alright? So then you have a look. Okay, which one would it be over here, right? And then you can see from there that what they have done is, okay, from here you shift this vector here, this will resemble this, right? So the answer is not probably, it is D, right? The rest you got to be very careful. You might think, this one is the answer, but you look, the arrow is different. Okay, so the main point I want to say is this: be comfortable with being able to shift your vectors about, move the vectors about. Okay, they can form a triangle. Okay, just remember when you shift them, then the magnitude must remain the same, the length of the force remain the same, the angles relatively must also remain the same. Okay, so I think that's all I want to say about vectors. Okay, you have to practice. It's not just good enough to listen to me, watch this video, just do some practice. Okay, be very careful. Remember always to use a good scale, label carefully your diagrams, okay, with arrows and so on. Okay, then it should be fine.